So we're doing 9.5 today. And 9.5 is traditionally, that's not a section sign. It's traditionally pretty difficult, okay? There's a lot of layers to this section. But if you can do the first example, then you can kind of do most of it. All right? Hey, Alex. Alex accidentally showed up to the college algebra stream, but he knew everything. He was like, this is easy. It was funny. All right. So let's start with example 1, and I can move my microphone. This is where I have it when I'm not standing up like that. All right. For example 1, we're just going to find all solutions to an equation. So find all solutions to these trigonometric equations. Now, the tendency right here is to say, we've done this before. I just use inverse cosine. You just type in inverse cosine of 1/2 into your calculator and you get 60 degrees. And that's not wrong, but 60 degrees is only one of the answers. There's a lot of answers, literally infinitely many answers to this equation. Okay, there are infinitely many, because, right, remember that cosine of coterminal angles is the same. So, right, 60 degrees is right here, but 360 plus 60, 420 degrees is also a solution. Add another 360, that's also a solution. Add another 360, that's also a solution. Exactly, because you can just keep adding 360, yes. But that's only half of the solutions. That's only half of the infinitely many solutions. Plus 2 pi k. So again, if you want to use inverse cosine, you can. But the way I like to think about it is using reference angles. Inverse cosine will oftentimes give you a reference angle, not always. Sometimes it does weird stuff with the negatives. But it's the angle of 60 degrees or pi over 3 that gets us here. Cosine of pi over 3 or 60 degrees is 1/2. But remember that there's 2 quadrants that this can occur in. Which 2 what? Which 2 quadrants is cosine positive in? Yeah, exactly. The first and the fourth quadrant. Good, Ashton. So that's what we're going to do for our answers. We're going to look at the angle in the first quadrant and every 360 degrees after that. And we're going to look at the same angle in the fourth quadrant, and again, every 360 degrees. So if you wanted to write this as negative pi over 3, you could. But it's kind of a good habit to write this as an angle between 0 and 2 pi. So what is this? This is going to be all the way 2 pi minus pi over 3. So this one appears pi over 3. The other one is going around all the way 2 pi, but then we go back pi over 3. It's a good way to find this. Or you could think about this as negative pi over 3 and then add 2 pi to get it into the interval 0 to 2 pi. Now this is pod racing. Oh, that movie. It's been too long since I've watched The Phantom Menace. So again, to combine these, we need a common denominator. Multiply by 3 over 3. You get 6 pi over 3. 6 pi over 3 minus pi over 3 is 5 pi over 3. Okay? So, we have 2 answers. But there are infinitely many answers, so we just have to add the plus 2 pi k to it. So our solutions are the first one, pi over 3, and every multiple of 2 pi getting added or subtracted to this. Okay. And the second one, wait, what did just happen, anonymity? What are you asking about? Now the second thing we found was in the fourth quadrant, which was 5 pi over 3. And again, every multiple of 2 pi added or subtracted to it. Right, k is any integer. I'm not going to make you specify that k is any integer, but for your own knowledge. That's how we do these problems. This is the foundation of this section. If you can get example 1 down, the section becomes much easier. If you struggle with example 1 and we're going to do a part B, It's going to be harder. Yeah, so I was just trying to find what angle the second one is in the fourth quadrant. So if you wanted to write this as negative pi over 3, that would have worked as well. But I wanted the interval, I wanted the angle that's in the interval 0 to 2 pi. So that's why I did this. I just subtracted these angles to find that it was 5 pi over 3, this one right here, which is the angle that if you go up all the way over right here, that's 5 pi over 3. Okay, and this is the foundation of the section, because later on we're not going to have it already solved for the trig function. Once we solve it for the trig function, we're going to use this method. So we're going to use this method on literally every single problem today. But later on, after example 1, we won't be starting off in this form. The multiplying by 3 was just me trying to get a common denominator so that I could combine these terms, right? Because we had just 2 pi minus pi over 3, and if you wanted to use your calculator to do this, as long as your calculator is set to give you exact answers, that's okay. My head's blocking it. But then I said, well, if I'm doing it by hand, we cannot combine these things unless we have the same denominator. That's why I multiplied by 3 over 3. I just realized I have no water here. I'm going to go get my water. Attendance question for day. Send me the name of a... oh my goodness. Send me the name of a fruit. Apple, melon, lemons. Okay? Send me the name of fruit for your attendance points. I got to get my water. All right, let's do example B. 1B. Same idea, just a little different. Sine of t equals -1/2. So just like before, we need to find a reference angle and we need to find what quadrant it's in. All right? So, again, I will give you these triangles. If I forget to give you the triangles, remember that you can always just message me on Discord. I will have my Discord open so you can get an immediate response during your quizzes and exams. All right, this is going to be 1, 2, root 3. This triangle is 1, 1, root 2. We're going to use these triangles a lot. Yeah. So, what reference angle gives us the 1/2? We need to find an angle such that the sine of that angle is 1 over 2. So it's going to be pi over 6. Or again, if you want to use inverse sine to solve this, you can as well. Yes, exactly, antonymity. 2 pi is a circle. Oh, I didn't see your earlier question, by the way. Yeah, so 2 pi is a circle, so we're just going all the way around the circle. It's coterminal angles. If you remember back to chapter 7, where we said like negative pi over 3 is coterminal with 5 pi over 3. Whether we go down pi over 3 or up 5 pi over 3, it's the same angle. So that's what we're doing here with the 2 pi k's. K is any multiple, so adding k can be 1, in which case we add 2 pi. K can be 2, then we add 4 pi, 3 to add 6 pi. So it's just getting all of the coterminal angles right here. All right. So we got pi over 6 as our reference angle, and then we need to figure out what quadrants is sine negative in. So sine's positive in the first and second quadrants. So sine's negative in the third and fourth. All right. And now we just do exactly what we did before. Theta is going to be something plus 2 pi k, and something else plus 2 pi k. All right, if you're asked to find all the solutions and you have no idea, but you remember the plus 2 pi k, just write your answer like this, okay? And then just fill in the blank if you can, but if you can't, that's okay. You can still get some partial credit that way. So we just need to find out what the angles are that have a reference angle of pi over 6 in the third and fourth quadrant. So in the third quadrant, it looks like this, pi over 6. The fourth quadrant, it looks like this, pi over 6. So we just need to find this angle. So again, this is going over pi radians, or 180 degrees, and pi over 6 more. So this one is pi plus pi over 6. For this one, you can think about it as going around all the way 2 pi, and then going back pi over 6. So 2 pi minus pi over 6. Now just simplify these answers and fill in the blank. Okay, so we just do what we did before. We need a common denominator. Yeah, we will be multiplying it by 6 over 6 for sure. Right here, was that your question? Because we're definitely going to do this. Because then we have 6 pi over 6 plus 1 pi over 6. That gives us 7 pi over 6. Yeah, good. And over here, we have to do the same thing, right? We're going to get 12 pi over 6 minus 1 pi over 6. That's 11 pi over 6. And those are our answers. A lot of good, I don't know, it seems like a lot of people are doing well with this section, which is really good to hear. Because this first example is really the foundation. And we're going to move on to more complicated problems right after this. Any questions, though, before we move on? Honestly, Brock, there's not going to be a but until the end of the section. Most of this section, if you've got this, Brock, most of the section, you'll be good to go. Because essentially, right, we just did example 1. Example 2 is going to be a little bit more complicated, but really example 2 is not that bad. Example 3 and 4 is where the but comes in, but we're not doing that for a while. Okay. So let's look at example 2. So before I go to example 2, right, I just want to do a little recap and talk about how exactly to solve these more complicated ones. All right. So the first step that we haven't had to do yet is to solve for the trig function. And again, you may need to factor or use identities. We won't really have to do this until examples 3 and 4. And then then after that, we just do it like we did before. Find the reference angle in quadrants. And then find the angles. So we've already done steps 2 and 3. We're just going to add step 1. If it's not already solved for the trig function, and again, what I mean by solve for the trig function is, again, let's look back at kind of my notes. These are already solved for the trig function. Cosine of theta equals blank. Sine of t equals blank. These are not solved for the trig function, right? Cosine has a 3 over here. Sine has a squared on it with a 2. This one's solved for the trig function, but we're not going to want reciprocal functions. All right, so let's get to it. Example 2. If you got example 1 down, I think this will be fine. Example 2 is also going to be a little different. And this is most of what I think the homework asks, almost exclusively this. So solve for all theta in the interval 0 to 2 pi. So now that we got the plus 2 pi k out of the way, we're going to say, yes, I know that you can add plus 2 pi k to all of your answers. We're just now only going to worry about 0 to 2 pi. And this is really common in a lot of situations, to only look at essentially each angle once. Because, right, what we did over here, we found two angles, and then we said, okay, every coterminal angle for those. But really, all we care about is these two angles most of the time. Not all the time, but a lot of the time. Okay. So, let's do part A. 2 cosine theta minus 3 equals negative 5. Sorry, that negative kind of flipped up. And again, some of these, this one's pretty straightforward to solve for cosine of theta. But some of them are a little less straightforward to solve for that trig function. If you want to go off to the side and just replace the cosine of theta with an x, you can actually just solve it the same way you would solve a regular algebra equation, right? Literally all of you know how to solve this. Just add 3 to both sides, divide both sides by 2. So if you wanted to solve it like this first, and then go back where x is the same as cosine of theta, you can do that. This form is probably not going to be so useful in part A, but when we get into like quadratics and stuff, it might be handy. Okay, so it's just something you can try if you want. But we need to solve for that trig function. We need to add 3 to both sides. All right. That gives us 2 cosine of theta equals negative 2. And then again, the cosine's still not by itself. We need to divide both sides by 2. You get cosine of theta equals negative 1. And now we're back to example 1. Okay? So remember that this is not going to be a triangle. There's no special triangle that's going to give you your adjacent over your hypotenuse to be negative 1. Yeah, I forgot the negative, so I tried to fit it in here, but it looks like there's not a negative here. Yeah, thanks for catching it. I do make plenty of mistakes like that, so I wouldn't be surprised if you were right. That's why I had to go back and look. So yeah, we're gonna have to use a unit circle for this one. Remember, on the unit circle, cosine relates to the x value, sine relates to the y value. So on the unit circle, again, where this is 1, this is 1, this is negative 1, this is negative 1, we need to find the place where the x-coordinate is equal to negative 1. Well, the x-coordinate is equal to negative 1 right here. And again, there's infinitely many angles that terminate right here. But we only care about the theta and 0 to 2 pi. So our answer is going to be 180 degrees or pi radians. And here, we are only going to have one answer because there's not 2, because there's only 1 point, and we're not talking about all the coterminal angles. And the best news about this section is that you can check your answer, okay? Right? If you have extra time on the quiz, and I am trying to give you guys extra time, I think that today's quiz you have 45 minutes to do. So I'm really hoping people are not rushed. I'm trying to give you extra time. If you have extra time, check your answer, right? If you plug in your answer, it should check out. Is 2 times the cosine of pi minus 3 equal to negative 5? So you just plug in the left-hand side on your calculator, making sure that it's in radians, if you're using radians, or degrees, if you're using degrees, and make sure that it equals negative 5. All right. And if you do, it will tell you, yes, it does indeed. All right. So let's do another one, unless there are any questions. Again, if at any point there's questions, you can, if you think you're going to take a long time to write out the question, you can still stop me with just typing the word question. Okay. And then I will let you have the time needed to actually ask it. But otherwise, I'm just going to keep on going. Let's do part B. All right. So 2 sine squared of theta minus 1 equals 0. So we got a squared now. It's a little different. And you might think, probably no one thinks this, but you might think, hey, why don't we use the power reduction formula? That's 9.3, which you have a quiz on today, the power reduction formula. We could get rid of the squared. And that's true. And you could solve it that way. There's nothing wrong with solving that way, but you don't need to. But you could. All right, there's a lot of ways to solve a lot of these. And again, if you want to go off to the side and say, well, what does this look like without trig? It's 2 times something squared minus 1 equals 0. Because we always want to solve for the trig function. We want to solve for x, essentially, on all of these. That's our first step to solving these things. Solve for the trig function. And again, later on, we may have to use like factoring, quadratic formula, or some identities. But here we don't have to, right? Just add 1 to both sides, divide by 2, and take the square root. So add 1 to both sides, you get 2 sine squared of theta equals 1. Divide both sides by 2, you get sine squared of theta equals 1/2. And be very careful right here, because we need to take the square root of both sides. But when you take the square root of both sides, you get a plus or minus. All right, and there's a long reason for where this plus or minus comes from. It's not that long, but the short answer is the absolute value of something the square root of something squared is actually its absolute value. They don't perfectly cancel out. And then when you solve absolute value equations, that's where the plus or minus comes from. If you are curious, and if you're not, well, you just got some bonus knowledge. I gave you a little freebie, free knowledge. So this one's a little weird, right? Let's keep simplifying. Well, the square root of 1 is just 1. The square root of 2, I don't know that. It's an irrational number. Yeah, bonus. All right. And now we have 2 equations. Remember, plus or minus means we have 1 equation with the plus, 1 equation with the minus. So a lot of times, it's good to split these up. You don't have to split this one up, but I like to. We have sine of theta equals positive 1 over root 2, and sine of theta equals negative 1 over root 2. So we can solve our triangles, find the reference angles, find the quadrants. And you get something kind of interesting here, but usually it's a good idea to split them up. Here, you don't really have to, but it's good practice to have each equation separately and then just solve both equations. So we need to find our triangle and say, what angle has a sine of 1 over root 2? And you get a pi over 4, or 45 degrees. Sine of pi over 4, 1 over root 2. Yeah, sure, Brock, what's up? Ah! So I sort of skipped a step. There's like an intermediate step where I said, let's take the square root of the top and the square root of the bottom, because these two things are the same. The square root of a fraction is the square root of top divided by the square root of the bottom, but the square root of 1 is just equal to 1. And that's why we lost the square root on the top. But I kind of did 2 steps at once right here. Thanks for asking. So we said our reference angle, well, the reference angle is the same for both of these, right? It's going to be pi over 4 on both. But in this case, this one's positive and this one's negative. So just like before, sine's positive in the first and the second quadrant, sine's negative in the third and the fourth quadrant. So really, we just need all the pi over 4s. We need pi over 4 in the first, second, third, and fourth quadrant. All of the angles that have a reference angle of pi over 4 in every single quadrant is going to be an answer to this question. So we just draw a little picture. And and find them out. So this is to be continued. All right, so draw a picture is usually a good idea. Pi over 4 reference angle in the first quadrant. Well, that's just pi over 4. Pi over 4 in the second quadrant looks like this. That's 3 pi over 4. You think about is pi over 2 plus another pi over 4. You could also have thought about it as pi minus pi over 4. A lot of ways to get to it. This one's 3 pi over 4. Third quadrant, reference angle of pi over 4. It's going to be 5 pi over 4. And the fourth quadrant, you notice the pattern, right? 1 pi over 4, 3 pi over 4, 5 pi over 4. This is going to be the Pac-Man angle, 7 pi over 4. So these are our 4 answers. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And again, we were only asked, what are all the answers in 0 to 2 pi? So we're not going to add the plus 2 pi k here, because we only want the core answers, if you will. And also remember that you can also, a lot of times we do think about this as negative pi over 4, but negative pi over 4 is not in the requested interval. Okay, so we have to use the positive version, the positive coterminal angle of negative pi over 4, which is negative pi over 4 plus 2 pi. And that'll get you 7 pi over 4 as well. All right. So yeah, let's just keep on going through these. We're going to see something a little different. I have a question for you guys. I want you guys to answer. Cosecant equals negative 2. No, I don't have a question for you. I'm just going to say something because there's 2 ways of doing this. If you love reciprocal functions, you can just solve it like this. Find out what reciprocal function cosecant has negative 2. But I do not personally like reciprocal functions. So I would personally solve this by turning it into sine. But you don't have to. If you are really good with cosecant, go ahead and use cosecant. Remember that cosecant is 1 over sine. And now, again, we need to solve for sine of theta. So we just take the reciprocal of both sides to get that sine of theta equals negative 1/2 is the reciprocal of the right-hand side. And I think have we literally already solved this problem? Yeah, this was literally the first 1B actually. All right. So we already solved this. All right. We got 7 pi over 6 and 11 pi over 6. So let's not solve it again. Right, solved in 1B. And our answers were 7 pi over 6 and 11 pi over 6. So that's how I deal with reciprocal functions. I just say, well, cosecant's 1 over sine of theta. Let's work with sine of theta instead. But if you want to use cosecant, be my guest. Sorry, I left off the T there. Okay, we're making good progress. If we can finish D and E today, that would be pretty crazy. So I took the reciprocal of both sides, which you can do. Another way that you could have done this step is you could have cross multiplied. Right? If you cross multiply, you get 1 is equal to negative 2 sine of theta. And then divide both sides by negative 2, and you'll also get here. A couple of different ways of approaching this one. But yeah, I just took the reciprocal of both sides, which is true, but cross multiplication works as well. I heard my cat jump off my chair, and I didn't see her literally anywhere. I got very confused, like a vanishing cat. Because yeah, if we finish D and E, we might be able to go a little bit more slowly on the harder problems. Good. Yeah, let's keep going. Tangent of theta minus pi over 2 equals 1. All right, so this is where things get a little weird. Now, there's a couple of ways of approaching this. Does anyone have any ideas? Actually, we're just going to finish D today and then go to the quiz. So the faster you answer D, faster we'll get to the quiz. Anyone have any ideas for this? There are a lot of ways of doing this. Complementary angles, yep, and cofunctions. That's what I would do myself. Any other thoughts? I would like to use the cofunction identity anyway. But if people have other thoughts, I'd be curious. Then notice if you're going to use a cofunction, what do we have here? We have theta minus pi over 2. But the cofunction identity is not exactly that. It's pi over 2 minus theta. The cofunction identity is actually the opposite of the inside of what we have. So this is almost cofunction. But we can make it. We can make it cofunction, right? We just factor a negative out of the inside, right? If I factor out a negative, we're left with a negative theta plus pi over 2. Factoring out a negative, this works. And we know that this works because we could undo it by distributing the negative to get positive theta minus pi over 2. So this is what we need to do to get it to become a cofunction. And now sort of two things happen right here, right? We can use a parity identity. Tangent's an odd function. We are using the identity sheet today, I guess. The book doesn't use the identities for this one, but I think it's easier with the identities. And we've just been using them all chapter 9 anyway. Right? Tangent's an odd function, so the tangent of a negative angle, the negative comes out in front. So this negative right here comes out in front, and we're left with negative tangent of, we can switch the order of addition. We have a plus pi over 2 and a minus theta. We'll just write those in the other order. The right-hand side's still 1. So again, I kind of did 2 steps. The negative came out in front because tangent's odd. And I switched the order of the inside, which we can do because it's addition. It's still a plus pi over 2, and it's still a minus theta. All right. And now, again, I'm going to do 2 steps at once because I do want you to get to your quiz in time. Multiply both sides by a no, I won't. Multiply both sides by a negative 1. You get tangent of pi over 2 minus theta equals negative 1. Just essentially multiplying by negative 1 to both sides because we want to solve for this trig function. And now we can use the cofunction because tangent of pi over 2 minus theta is exactly cotangent of theta. So we get cotangent of theta equals negative 1. Wait, which messed up one? And now I would solve this. Again, there's a bunch of ways to solve these things. I would solve this the same way I solve C. I don't like reciprocal functions. Let's write it as tangent. You can't really use inverse cotangent. Calculators don't really have an inverse cotangent. So if you want to use inverse, you're going to have to write it as tangent first. Cotangent's 1 over tangent. Or cosine over sine. I would recommend not using cosine over sine though, because then you have multiple trig functions. And we're not dealing with multiple trig functions yet. Okay. I messed up one that I did in the other class, so I think I wiped it from my memory. And just like before, we can take the reciprocal of both sides. So the reciprocal of the left-hand side is just tangent of theta. The reciprocal of the right-hand side, well, the reciprocal of negative 1 is just negative 1. Right? So that's kind of weird. It looks weird, but we just take the reciprocal of both sides. We're just flipping this side and flipping this side. Math is whack. Well said. So we need, if this were sine or cosine, remember, sine or cosine equaling negative 1. Oh, crap. We're running out of time. You have a quiz to take. I'm going to go through this real quick. Tangent of theta equals negative 1. That's a reference angle. You could use inverse tangent to do this as well. It's going to be pi over 4. And it's negative, so it has to be in the second or the fourth quadrant. So we're going to get 3 pi over 4 and 7 pi over 4. All right. And you need to take your quiz I don't want to keep you late. So go ahead and I'll upload these notes. If you didn't finish writing them down, copying them down yourself, go ahead and take the quiz. It should be open, and good luck. All right. And remember, no class on Friday. Friday is a holiday. It's Easter holiday. All right. I don't know if your other classes are getting canceled on Friday, but I'm giving you a break. All right. Friday will still be a holiday for this class. So we will meet again on Monday. Good luck.